You have a bucket of 500 coins. 499 are normal coins, but one of them is a double-headed coin. You draw a coin randomly for the bucket and then you flip it 5 times. Question 1. If you picked a normal coin, so if you drew a normal coin, what is the probability of flipping 5 heads? Question 2. What is the probability of flipping 5 heads in general, just from this situation? And lastly, what is the probability of picking a normal coin having obtained 5 heads from flipping the coin that was drawn? Now from this last question, you can tell that we are trying to calculate a probability using or knowing some new piece of information. In this case, is the knowledge that we have flipped 5 heads using this random coin. Hence, this is a question regarding Bayes' theorem listed on the right. So the probability of event A given event B is equals to the probability of event A, so known as the prior, and this is scaled by some fraction, which is the probability of event B given A normalized or divided by the probability of event B. So to break down this equation, we can think of it as the posterior, so our posterior estimate of probabilities. In this case, the posterior estimate of the probability of event A on the left is equals to the prior estimate of this, which is just probability of event A. And this is scaled by some, you could think about it, scaling coefficient. And this is represented by the fraction. Now, at this point, I like to just write out all the probabilities that I can just obtain just from the question description itself. So here we have some straightforward ones. The probability of picking a normal coin, there are 499 of them out of the 500. Therefore, it's 499 over 500. And the probability of picking a double-headed coin, which is 1 out of 500. Now, focusing on a normal coin, what is the probabilities of having a heads or a tails, right? Because this is a normal coin, we only have 2 outcomes from when we flip one, a heads or a tails. And you will agree that it is half and half for both of them because it's a fair coin or normal coin in this case. Whereas for the double-headed coin, because it is double-headed, the only outcome you can get is heads. Therefore, the probability of drawing a heads or flipping a heads using a double-headed coin, or in mathematical speaks, the probability of flipping a head given that you have a double-headed coin is just 1 because you'll always get it. And the probability of getting tails having the double-headed coin is obviously 0 because it's double-headed. So let's address question 1. If we picked a normal coin, what is the probability of flipping 5 heads with this normal coin? So we flip it once, twice, 4 times, 5 times. What is the probability of getting 5 hits? Now, because these are 5 flips, 5 independent flips, so each flip does not affect the other, we can say that the probability of having 5 hits, given that we have a normal coin, is just half times half times half times half, 5 times. So 1 over 2 to the power of 5, which is just 1 over 32, right? Because there's 5 independent flips, each of them having, with each outcome having an equal opportunity of occurring. And you can also say that the probability of getting 5 tails will be the same thing, right? Because the probability of getting a heads or tails on a normal coin is the same. And for the sake of completeness, let's also calculate the above but for a double-headed coin. So the probability of getting 5 hits, assuming you have a double-headed coin, is naturally just 1. Because you're always going to get a head with a double-headed coin, therefore it's 1 to the power of 5, which is just 1. Right? So that answers the first question. The probability of getting 5 hits, given that we have a normal coin, is 1 over 32. Now for the second question. What is the probability of flipping 5 hits? So we know that we have flipped a coin 5 times, right? But this coin could either be a double-headed coin or a normal coin. So what is the probability of us just getting 5 hits, right? Regardless of what type of coin we have. So we can say, and I hope you are following, that the probability of getting 5 hits is the probability of getting 5 hits with a normal coin plus the probability of getting 5 hits with a double-headed coin. Breaking that down further with more mathematical notation, it is the probability of getting 5 hits. It's the probability of the event of 5 hits intersected with the event of getting a normal coin, plus the probability of the event of 5 hits intersected with the event of getting a double-headed coin. And breaking this down further, using the laws of conditional probability, we can see that these two terms here break down into these 2 terms here, right? Using this equation here. So let's think about what we have, right? On the left here, we have the probability of getting 5 hits given we have a normal coin multiplied by the probability of having a normal coin. And similarly for the second term. And if you think about it, we already have all these probabilities. This is what we will list. This is what's listed above us. Hence, is plugging in the values, we should get this. 1 over 32 times 499 over 500 plus 1 times 1 over 500, which gives us 0.03318, right? So this is the probability of getting 5 hits. Hence, going back to our question, going back to our last question, what is the probability of picking a normal coin having obtained 5 hits from flipping the drawn coin? So expressing that in mathematical terms is the probability of getting a normal coin given that we have flipped 5 hits. So using Bayes Theorem, we can break this down into the probability of getting a normal coin, our prior, multiplied by this scaling coefficient, right, this fraction. So it's the probability of getting 5 hits given that we have a normal coin, normalized by the probability of getting 5 hits in general. And these 3 terms we have already calculated from either the question itself, based on the description, or from parts 1 and 2 above. So just plugging in the values, we will see that the answer for part 3 is 0.9399. Great, you've answered the question. At this point, the interviewer may now ask you, does this result make sense? Why or why not? So let's think about what we have so far. So we started with a prior. We started with a prior estimate of flipping. We started with a prior of the probability of getting a normal coin here, which is just 499 out of 500 because there are 499 coins, normal coins out of 500 coins. And then we drew a coin and we had some new information about this having flipped 5 hits. So let's think about it. Now our posterior estimate of probability of getting a normal coin is 0.9399, right? And if we just express the prior in a decimal form, just to make it easier for us, what we have is the probability of getting a normal coin, the prior, is 0.998. And now what you will notice is that our posterior, 9399, is lower than our prior, 0.998. Why? Why has the posterior changed and lowered slightly compared to our prior? So let's think about what this new information is. This new information that was given to us was that we obtained 5 hits, right? And the fact that we obtained 5 hits, this new information actually supports the other outcome, which is us having a double-headed coin. Because the probability of flipping 5 hits using a normal coin is so much rarer compared to that of a double-headed coin, that this new information that we have is actually supporting the fact that we might actually have a double-headed coin. Therefore, this posterior estimate of the probability of getting a normal coin has dropped. It's dropped a little bit. Why? Why did it drop a little bit? Because overwhelmingly, most of the coins are still normal coins. Therefore, it's still likely that we have drawn a normal coin. But it's dropped a little bit because we know that this new evidence doesn't support us having drawn a normal coin. It actually supports us having likely drawn a double-headed coin. Hence, we see this very small drop in the from the prior to the posterior estimate. Now, depending on the structure of the question, you might actually see that this prior to posterior drop in probabilities, or maybe increase, depending on the question, can actually be quite large. And if you want such a question, please refer to the other Bayes question that's found on this playlist on the left. And if you would like to learn more about my recent experience and also my mistakes from my recent quant interviews applying in London in the year 2023, please refer to the playlist on the right. And don't forget to like and subscribe. Thank you.